the sum and product of the roots of a quadratic equation. Our learning targets are: describe the relationship between the coefficients and the roots of quadratic equation. Then, determine the sum and product of the roots of the quadratic equation. We have seen that the b squared minus 4ac portion of the quadratic formula, called the discriminant, can tell us the type of roots of a quadratic equation. The quadratic formula can also give us information about the relationship between the roots and the coefficient of the second term and the constant of the equation itself. For us to find out the sum and the product of the roots of the quadratic equation without solving for the roots, we can use the following formula. The sum of the roots is the additive inverse of the quotient of b and a. So it means that x sub 1 plus x sub 2 is equal to negative b over a. For the product of the roots, it is the quotient of c and a. So it means that x sub 1 times x sub 2 is equal to c over a. Let us now have our examples. For the first one, without solving for the roots of x squared plus 6x plus 9 equals 0, let us determine the sum and the product of the roots. The first step is to write our equation on its standard form. Since this is already on ax squared plus bx plus c equals 0, we will now determine the values of a, b, and c. A is equal to 1, b is equal to 6, and c is equal to 9. Now, let's proceed in solving for the sum of the roots. Let us write the formula. We have x sub 1 plus x sub 2 is equal to negative b over a. Let us substitute the values. B is equal to 6 and a is equal to 1. So we have 6 divided by 1, or negative 6 divided by 1. Now, let us simplify. Negative 6 over 1 means negative 6 divided by 1. So we have negative 6. So the sum of the roots is negative 6. For the product of the roots, we have c over a. C is equal to 9. A is equal to 1. So we have here 9 over 1, which means 9 divided by 1. 9 divided by 1 is 9. So the product of the roots is 9. To find out if we have the correct answer, let us solve for the roots of x squared plus 6x plus 9 equals 0. By factoring, we can solve for the roots. The roots are negative 3 and negative 3. So it means that the sum of the roots means negative 3 plus negative 3, and that is negative 6. Now, for the product, we have negative 3 times negative 3. Negative 3 times negative 3 is 9. So it means we got the correct answer. Without solving for the roots of x squared minus 3x minus 28, let us solve for the sum and product of the roots. Since this is already on the standard form, let's determine the value of a, b, and c. A is equal to 1, b is equal to negative 3, and c is equal to negative 28. Now write the formula for the sum of the roots, and that is x sub 1 plus x sub 2 is equal to negative b over a. B is equal to negative 3. A is equal to 1. So we have negative of negative 3 over 1. Negative of negative 3 means positive 3. Divided by 1, we have 3 over 1. And 3 over 1 is equal to 3. So the sum of the roots is equal to 3. For the product of the roots, our formula is c over a. C is equal to negative 28. A is equal to 1. So let's substitute the values. We have negative 28 over 1. Negative 28 over 1 is equal to negative 28. So the product of the roots is negative 28. Let us find out if we have the correct answer by solving for the roots of our quadratic equation x squared minus 3x minus 28 equals 0, and we will use factoring. Based on our solution, the roots are 7 and negative 4. Let us find out the roots, the sum of the roots. So the sum of the roots means 7 plus negative 4, and that is positive 3. For the product of the roots, we have 7 times negative 4, and that is 7 times negative 4, negative 28. So we were able to solve for the sum and the product of the roots without solving first for the roots of the equation. For our last example, we have here 2x squared minus 4x is equal to 1. Let us determine the sum and the product of the roots without solving the roots. The first step is to write the equation on the standard form ax squared plus bx plus c equals 0. Therefore, we have 2x squared minus 4x minus 1 is equal to 0. Now, let us determine the values of a, b, and c. From the equation, we have a is equal to 2, b is equal to negative 4, and c is equal to negative 1. Let us solve for the sum of the roots. Write the formula. We have x sub 1 plus x sub 2 is equal to negative b over a. Let's now substitute the values. B is equal to negative 4. A is equal to 2. Therefore, we have negative of negative 4 over 2. Negative of negative 4 over 2 is equal to 4 over 2 because negative times negative 4 is a positive 4. So we have 4 over 2, and 4 divided by 2 is equal to 2. So it means that the sum of the roots is 2. For the product of the roots, we will write x sub 1 times x sub 2 is equal to c over a. Let us substitute the values. C is equal to negative 1. A is equal to 2. So we have negative 1/2 or negative 0.5. So these are our final answer. The sum of the roots is 2. The product of the roots is negative 1/2. Thank you for watching this video. For your questions and clarifications, you may ask them during the Zoom meeting or you may send them on the class group chat. Good luck and God bless you all.